Hello everyone, I am myself Ashok and I am from AMC Engineering College from Civil Department. I am currently studying in 6th semester. Our project is on the software of use of road embankment analysis using slope W software. And here are my teammates, they introduce about themselves.
Good morning everybody, my name is Hariharan. I am studying in AMC Engineering College in 5th semester. Then my teammates is Ganjay.
Hello, I'm myself Jan Joy I'm from Manipur and I'm studying in AMC in college. And here are my teams, and we are about to we are about to give a project about road mapping using a slope software. And after this, my friend will give the details.
Myself Rashmi, I am from AMC Engineering College, studying in 3rd year.
Okay. The introduction about the software is basically used for slope stability analysis to evaluate the spectroscopy of the slopes, so that further failures, so that in future after the construction of the slope there will be further modeling for the slope. And it's commonly used in geotechnical engineering, mining and infrastructures developments, and road embankment analysis and road slope developments. And the objective of our project will be explained by Christine.
Here is the objectives of road embankment: to learn using a slope W software of analyzing road embankment, to understand the effect of change of height of a road embankment on the slope stability. Next, Ashok will explain next slide.
When it comes to methodology, the methodology starts with the initial geotechnical investigation. Like we have to visit the site and collect the visible data, which can be used for modeling, and then we have to pass local knowledge, or past knowledge and local knowledge, so that from that we can get to know about the soil properties and so what are the features of the particular region or the area. And first pass design, and then next step comes to the first pass design. The first pass design is nothing but the model which can be used, or which is certified. And next it comes to the construction. The model tank should be constructed, and then additional geotechnical investigations and trial embankments, infrastructure, instrumental and monitoring. Okay. Then it comes to the calibration of the design. If any errors need to be done, if any errors are coming, so that we have to change calibrate the model's angles or rise of the height. And next it comes to the modification of the construction if required, and then prediction of long term of embankments. Like the design model should be usable for a long period of time, so that it reduces the cost and effects by the next. And it comes to the final. When it's done, it can be proceeded in the next further.
Next, for analysis of stability in geotechnical engineering, to evaluate stability of slopes under different conditions and identify the critical slope angles for different soil types. Then in 2018, concern the impact of the vegetation on the slope erosion. To study how we affect slope erosion, vegetation and signification reduces slope erosion. Then 2018, broad scale climatic change effects on slope values, to assess the impact of rainfall intensity on slope values. Then increase the rainfall intensity correlates. The procedure for the project is first should be done for site investigation, collect geological and geotechnical and hydrological data including soil properties, slope calculations. Failure mechanisms identification, identify potential and failure modes such as rotational, transitional or wedge failures. It means should calculate the failures of the projects, uh, slope failures, and stability modeling develops the slope models using the analytical and numerical methods interacting soils, properties, geometric and external forces. It is the meaning of the external forces we should calculate from the slopes we done in projects. Then factor of safety calculation, evaluate the FOS using methods like limit equilibrium, finite element or finite difference techniques to assess slope stability. With the finite elements and finite equilibrium is technique to calculate the slope stability for further process. Sensitivity analysis analyzes the impact of varying parameters such as soil strength or water table levels on stability. We should calculate the stability of slopes for finding this water level in the different levels of water in parameters. Examples of pavement and original expressway, slope of cutting sections, old embankment after excavation, filling soil of old embankment. It is the graph of the previous model of slope stability. Next, Ganjay will be explaining about this topic.
Here are the steps for using the software. In step number 1, we have to create a file and select the type of analysis. Like there are different types of analysis here. We can use ordinary, V-soaps, and etc. And after that, we have to select. As my friend explained about the procedure to limit the equilibrium. We have to limit the equilibrium here. And step number 2, we have to define the slope structures and define the swells elevation. And we have to define the height elevation for the structures. And here are the elevation and the same here for the slope. This we have to define the property of soil here. In step number 3, we have to select the types of material here, and after that we have to start analyzing. Here is the type of soil type. We have to select pores, water, the soils, and here are the elevation in this case. These are the output. Factor of safety are here, and we have to select which one is the better impact of outcome. Here is the last outcome. Here is the result of. Here are the results after using the Microsoft software. These are the factor of safety and slip surface. These are the different slip surface and factor of safety. Here are the outcome after using the Microsoft software. These are the factor of safety among the slip surface. We have to select the critical surface, slip surface. This is the most critical slip surface among the slip surface.
Here is the conclusion. The analysis of the road embankment slope W software confirms that stability with an adequate factor of safety under a static and dynamic conditions. Sensitive analysis highlights the importance of drainage and reinforcement in critical zones. Thank you.
Thank you.